This is a discussion on the mole concept. You should have already printed out this handout that you're seeing, the overview of the mole concept. It's a PDF. The mole concept is a way in which we will be able to do or see several things about our base units, base particles. Remembering that the base particles are for elements, they're called atoms. For molecular compounds, they're called molecules. And for ionic compounds, even though the base particles are ions, you need to account for both positive and negative ions, so we call them formula units. Any one of those base particles are too small to count, to mass, or to find the volume of that particle. So therefore, what we've done is we've created a system, and the system is a grouping system, so that if we group these particles in large enough amounts, we can actually weigh something and know how many of those particles we have. Therefore, we can measure something that is not actually able to be measured. The group number, as in how many of these base particles we need to group together to be able to do this, is 6.02 times 10 to the 23rd particles. That number is called Avogadro's number because the concept of the mole is based on, or started with, a man named Avogadro in the 16 or 1700s. The name we give the grouping amount, 6.02 times 10 to the 23rd, is called the mole. The mole is actually a unit that will allow us to go between three different properties. The first one is a mole can be related to the counting of particles, or the mole can be related to the massing of particles, or to the volume of particles. Now with the volume, it's a little more technical. It's only for gases, and the gases have to be at what they call STP, which is called STP stands for standard temperature and pressure, and that's a certain temperature, 0 degrees C, in an atmosphere of pressure. So what we can now do is we can create three separate mathematical relationships between the mole and one of the three properties that we can create: mass, massing, counting, or numbers of things, or volume. You should have done each one of these already, because this should be a review. So if you scroll down a little or look at the page, what I did is I related them all together in one string. 1 mole is equal to, if you're counting particles, 6.02 times 10 to the 23rd particles. If you're massing it, it's equal to the atomic mass, which we're going to change that to a different name called molar mass if we're talking about any kind of particle or any kind of substance. Atomic mass is the name for just atoms. And then 1 mole is also equal to 22.4 liters of any gas at STP. So the three different calculation types, the first one has to do with massing, and that to do the calculation, if you're a dimensional analysis person, you'll be using the conversion factor of atomic mass. Again, the more expanded name will be molar mass, which is the mass of 1 mole of anything. But the units will be the same, which is grams of something over 1 mole of something. and there will be a separate discussion on how to calculate molar masses. So that's the conversion factor you would use. Of course, you would get the atomic masses from the periodic table, and the molar masses you'd get from a calculation using the atomic masses. So if you're an equation person, what you would do is the equation is number of moles is equal to the number of grams over the atomic mass or the molar mass, which you don't use the word atomic mass or molar mass, you use the actual units that you see on the page. So that's how you do questions that go from mass to mole or mole to mass. If you're going to do some counting or figure out the numbers of base particles, you use for dimensional analysis, you use the relationship 6.02 times 10 to the 23rd particles per 1 mole. And if it's an equation, it's the number of moles is equal to the number of particles over, and then in parentheses on the bottom, 6.02 times 10 to the 23rd particles per 1 mole. Now, for these, the word particle is a general name. So instead of having 3 different equations, because you have 3 different types of substances in nature, what we did is we created a general name, particle, and therefore what we need a little table to differentiate. So when you're actually doing calculations, you have to determine what kind of substance it is. If it's an element, then you're not going to use the word particle, you're going to replace it with atom. So wherever you see a particle, you replace with atom. If it's a molecular compound, you're going to use the word molecule instead of particle. And if it's formula units, ionic compound, you're going to replace particles with formula units. Now, the only abbreviation you can make is for formula units, and you can use the abbreviation as long as you don't put anybody's name next to the abbreviation, which is FU. Okay, so therefore, when you do the calculations, you have to first know what substance is talked about in the calculation. But don't forget that now, if you have the rule is if you have a number, you have a unit. But if you have a number in a unit, you must have a symbol next to it, so you will be able to know if it's an element molecular compound or ion compound. And then the final one, which you can use, and it's only for gases, is volumes to moles or moles to volumes. And that conversion factor is 22.4 liters per 1 mole at STP. And that STP is just kind of like a tag you leave on the side. Because when we get to the gas laws in the spring, you will need to do a little bit more work on that, a little bit more explanation. So if you're going to use the equation, number of moles is equal to number of liters over 22.4 liters in 1 mole. And then you use the at STP on the side. Okay, so that's the 3 equations that you use. And again, you determine which one to use by what the question's asking for. So I hope that helped. Thank you.